In this video, we are going over domains and codomains a little more in detail. So I got a couple examples set up. Before I go through those examples, I kind of want to just redefine what domains and what codomains are. So I can do that. I'll do that on this side. So I'll section this whole thing off, and then I'll define the codomains on the right side of this black line, or the domain and codomain again. So a domain of a function, the domain of a function, the domain of a function is the set of all elements that may be input into the function. Okay, that's the definition of the domain, which I already defined in previous videos, but for the sake of completion, I wanted to redefine it here. And then I'll redefine the codomain. The codomain, aka the range. The codomain, aka the range of a function, is the set of all elements. The set of all elements that are mapped from an input. Of a function. Another way of saying this is the set of all outputs. So I could have said that too. Now, those are the definitions. Now let's do a couple examples just so that it's clear, how these domains and codomains can turn out. So I got this function f of x right here written in blue, and f of x is equal to x squared. And then right here, what I just boxed off, this is telling you that f is a function that maps inputs from the real number system to outputs that are in the real number system as well. So this notation that you see here, this is giving you more context surrounding your function. It's telling you so that there's no ambiguity. Remember, we don't like ambiguity in math. We like precision of language. And so here, this is adding more context for the sake of precision to tell you that f is a function that maps real numbers to real numbers. So that there's no ambiguity. And right now that may be obvious, but I have a later example in which it's not so obvious and where this clarity is necessary. And I'll show you that in a bit. But right here, I want to think about and talk about what the domain of f of x is. So what inputs can go into f of x? Pretty much any real number. You can put a negative number there. You can put a positive number there. It doesn't matter. Any input can go there. So the domain of this the domain of f of x is all real numbers from negative. You can say you can write that multiple ways. You can say all real numbers. So you can say all and then put that little R with the double back on there. And that means real numbers. You could do that. But what you'll most likely see it written in set notation. And set notation looks like this. It'll say from negative infinity to positive infinity. And that's how you say all real numbers in set notation. I just said that the domain is all real numbers from negative infinity to positive infinity. Now let's think about the codomain or the range. The codomain is not all real numbers. It's a real, the codomain is a set of elements from the real number system, but the codomain is not the entire set of the real number system. And let's think about why. F of x is equal to x squared. Anytime you square a number, you're gonna get a positive number. If I take in a negative number, if I input a negative number, let's say negative 4, f of negative 4 is equal to negative 4 squared, which is equal to positive 16. And if I were to do f of positive 4, f of positive 4 is equal to, again, is equal to 4 squared, which is equal to, again, 16. So my codomain is limited. My codomain can't have any negative numbers in it. Why? Because of the way the function is defined. The way the definition of the function, this determines what your domain and codomain can be. And because the function is defined to square whatever the input is, and anytime you square a number, you get a positive number. Because of that, our codomain is only going to ever be positive. Our codomain can only ever be positive. So I'll write the codomain in set notation. The codomain, it can be 0. If we put in f of 0, we'll get 0 out. So if we input 0, then our output is 0. And then it could pretty much be any number that's positive. You give me a positive number, I can give you an input that maps to that positive number. If you give me positive 25, then I can give you actually 2 inputs that map to positive 25. One would be negative 5. Another one would be positive 5, because f of negative 5 equals negative 5 squared, which is 25. And f of positive 5 would equal 25 squared, which is 25. So in the codomain, we can have any number that is positive, or let me correct that. We can have any non-negative number, because 0 is in the codomain and 0 is technically not considered positive. So how do we say all non-negative real numbers in set notation? How do we say that? We would say from 0 to infinity. And notice that I didn't use a parenthesis here. I used a bracket, and that is done on purpose. That is done to say from 0, including 0, all the way to infinity. Now, if I had just used a parenthesis, then what I would be saying is from 0, not including 0, all the way to infinity. But we do want to include 0 in our codomain because there is an input 0, f of 0, which maps to 0. F of 0 maps to 0. So 0 is in our codomain because there is an input that maps to 0 as an output. So this would be our domain and codomain of f of x. Now let's look at g of x. Let's look at g of x. So g of x is equal to the square root of x, and g is a function that maps from the real numbers, so it takes in real number inputs, and it spits out only real number outputs. Now, that's going to be important. That's an important clarification, and I'll show you why. I will show you why right now. So the domain, because we know, because we've received clarity that only real numbers can go in and only real numbers can come out, that's going to inform us on what numbers are allowed in our domain. You might be tempted to say the domain is any number from negative infinity to positive infinity. But that's not true in this case. And that's not true because if we input a negative number into this function, into g of x, let's say we input g of -4. G of -4 is equal to, let's do g of -1 actually, instead of -4. Let's say we input -1. G of -1 is equal to the square root of -1, which is equal to I. I is not in the real number system. You see that? I is not a part of the real number system. And we know from here that G maps real numbers to real numbers. So because we know that G is a function that's mapping real numbers inputs to real number outputs, if we have an input that produces a number that's not a real number as an output, so in the case of G of -1, then we know that that input isn't permitted. That input is not in the domain. So because of this definition here, I'll box it off again. Because of this definition here, we know that our input, it can't just be anything. It can only be the real numbers that map to real numbers. And the real numbers that map to other real numbers for this function, g of x, that's going to be any non-negative input. So our domain can only be non-negative in this case, even though you might be tempted to say that our domain can be all the real numbers, negative, positive, whatever. In this case, because we know that because G is defined as a function that maps real numbers to real numbers, not complex numbers, that because of this definition here, that's going to cause us to have to restrict our domain. And so we have to restrict our domain to the inputs that only produce real number outputs. And for this function, g of x, that's going to be all the non-negative inputs. And so our domain is going to be all the non-negative numbers. So from 0 to infinity. Now, what is our output going to be? Our output is going to be, what is our codomain going to be? Our codomain, you can't square root a number and get a, you can't square root a number and get a negative number. You can only square root a number and get a non-negative number. I can't There's no number I can take the square root of and get -1. There's only one, there's only the non-negative numbers can be produced from this function. And so our codomain is going to be all the non-negative numbers, which is all the numbers from 0 to infinity. Now, let's go on to another example. I got another function, and we'll call this function h of x. And h of x is very similar to g of x. H of x is defined as the square root of x, just like g of x is defined as the square root of x. But h of x is defined as a function that maps real numbers to the complex number system. Unlike g of x, which maps real numbers to the real number system, h of x, you can map it to the complex number system. And so before I go on, I want to give a quick reminder, just a very, very quick reminder. A complex number looks like this, where a and b are real number coefficients, and where a and b, this is what a complex number looks like, where a and b are real numbers, and I is defined as the square root of -1. Now, b can be 0. B is allowed to be 0. So if you have, let's say a is equal to 1 and b equals 0, then your complex number would be 1 plus 0i, which is just 1. So when you have a number in the complex number system, it often will have both a real component and an imaginary component. But even if it doesn't have an imaginary component, it's still considered a part of the complex number system. The complex number system it includes all of the real numbers plus imaginary numbers. So it's perfectly fine. It's perfectly acceptable for an output in the complex number system to not include an imaginary component. That doesn't mean it's not a part of the complex number system. The complex number system includes all of the real numbers plus plus imaginary numbers. So our output, just because the output, the codomain, is in the complex number system, it does not mean that that every output has to have an imaginary component. It just means that the outputs can have an imaginary component. So that was a quick aside. And now we'll continue with this example. I'm going to erase this to make some space, to give myself some more space. And let's go through this example and let's figure out what the domain and what the codomain is. Now in g of x up here, because the codomain had to be a part of the real number system, meaning it could not have any outputs that had an imaginary component, because of that, it restricted our domain because we couldn't put any inputs in that would produce any complex numbers. But that restriction down here, we're freed from that. We can have outputs that include imaginary components. And so that's going to change our domain. That's going to make it where in g of x, where we couldn't have negative numbers because it would produce a complex number if we had negative numbers in a domain. In h of x, we can have complex numbers as outputs. And so we don't have to restrict our domain like we did in G of X. In H of X, our domain can run wild. Our domain can be all the numbers, negative and non-negative numbers, from negative infinity to positive infinity. And let's think about what our codomain is. Our codomain, which is all of our outputs, all the possible outputs that can go in there. Our codomain, let's think about it. Can we get any negative numbers? We can get imaginary numbers, but can we get negative numbers? If I take some real number, throw it into this function, whether it's negative or positive, even if I take negative numbers. So let's do the example h of -1. That's not going to get me a negative number. It'll give me an imaginary number, but it won't get me a negative number. It'll get me I. So our codomain can be a real number. Our outputs can be either a real number or it can be an imaginary number, but it can't really be a negative number. We can't get a negative real number and we can't get a negative imaginary number. So the only numbers we can get, if we input a positive number, it's going to output a positive real number without an imaginary component. So our codomain is the set of all non-negative real numbers. So from 0 to infinity. So this is me saying all the non-negative real numbers from 0, all the numbers from 0, including 0, all the way to infinity within the real numbers, or within the real numbers. And so that's one type of output we can get, and we get this output anytime we input a non-negative real number into our function, into h of x. Let's say I put in 1, then I'll get out the square root of 1. That's a real number between 0 and infinity. Let's say I did h of 16, I would get positive 4. Again, that's a real number between 0 and positive infinity. And so that's what I have written here. But there's also another kind of output that we can get. And we get that output if we input a negative number. So if I did h of -1, I would get I. If I did h of -4, I would get 2I. If I did h of, if I did h of -9, I would get 3I. If I did h of -16, I would get 4I. So you can kind of see a pattern forming here. The outputs, when we put in an input that is a negative real number, we get an output that is a complex number, but it's not just any kind of complex number. It's going to be a complex number where instead of having both a real component and an imaginary component, instead of it looking like this, it's not going to have that real component. It'll just look like this. So that's going to be our codomain. Our codomain is going to be the set of all complex numbers that don't have a real component, that only have an imaginary component. And so now let's see, how do we write that? How do we write that out? I'll show you in just a second. Let me erase this. Erase that, and then let's write out the second part of our codomain, because we already wrote out one part of our codomain. If we input positive numbers, say 1, 4, 9, then we get out some positive real number. But if we input negative numbers, then we get out some number of the shape, this shape. We'll call it A, I, where A is in the set from 0 to infinity. So this is our codomain. This is how we define our codomain. We just defined it based on what outputs we get, based on the inputs that we're allowed to insert. If we input positive numbers or non-negative numbers, then we get something from this set. If we input negative numbers, then we get something from this set. Okay. And that's pretty much it. Every function is going to have a different codomain and domain based on how it's defined. And you can, as we can see here, you can affect the codomain. You can affect the domain and the codomain based on how you define the function. Here we got g of x equals square root of x, and the domain and codomain are both real numbers, and so that meant the domain and codomain could only be as a consequence of us defining the domain and codomain as only real numbers, as a consequence of us restricting our domain and codomain in such a way. This is what we were left with as a domain and codomain. Now, h of x, which is the same function essentially, but with different restrictions, we ended up getting a different domain and codomain. Same function, different restrictions. So when you're trying to figure out what your domain is and what your codomain is, you have to consider what your restrictions are, so that you can figure out what your domain and codomain is. That's it for this video. Peace.